Hi guys, I want to show you how to do some advanced factoring. I'm going to call it factoring by splitting the middle. In order for you to follow me along in this video, you're going to need to know a couple things before you start watching. So I'm going to kind of go over those things that you need to know, and then I'm going to go into how to factor by splitting the middle. First, you need to know how to find the greatest common factor of an expression, and you need to know how to factor out the greatest common factor. A simple example of that might look like this, where the greatest common factor is 4. And so we write the expression as, 2x plus 3 times 4. So I have two factors there, 4 and 2x plus 3. A tougher example of factoring out the greatest common factor involves factoring by grouping, it's usually called. And I'll show you what I mean by that. So let's say you had a problem like 3x squared plus 5x plus 4x plus 20. You'd have to start factoring this expression by grouping. So you might group like this. And in each group, you'd factor out the greatest common factor. Well, the greatest common factor over here is 3x. You'd be left with x plus 5. And over here, the greatest common factor is 4. So when I factor out 4, I'm left with x plus 5. And I end up with these two terms. And in both the terms, the greatest common factor is x plus 5. So to factor that, I end up with x plus 5 times 3x plus 4. Okay. If you're going to follow along in the video today, you're going to need to know how to factor by grouping like I did here. And how to get this answer. I showed you how to do that in another video. So if you're stuck with this, you might want to stop the video right now and go watch the video on factoring by grouping. I'm also going to expect that you know how to factor using the sum product rule. And prior to watching this video, you should be able to factor a problem like this. X squared plus 7x plus 10. And you would know that you're looking for two numbers that add, that have a sum of 7 and a product of 10. That's where the sum product rule is. So if you looked for numbers that have a product of 10, you might think 1 and 10 multiplied to 10, 2 and 5. And that's all the whole numbers, which is usually what we're looking for when we factor. And we need the two that have a product of 10 and a sum of 7, so you'd pick 2 and 5. And you'd know then that to factor this equation, or this expression, sorry, it factors like x plus 2, x plus 5. Here's another example of the sum product rule. X squared minus 7x plus 12. Okay, so we need two numbers with the sum of negative 7 and a product of positive 12. Well, if you've done a few of these, you're going to get better at this, noticing that if the two numbers have a product that's positive, they're either both positive or both negative. And if they add to a negative number, that means they have to both be negative, right? Because two positives would never add to negative 7. So I'm thinking, what do you multiply to get 12? Well, you could multiply 1 and 12, 2 and 6, 3 and 4. And if they're both negative, negative 1, negative 12, negative 2, it's going to have to be negative 3 and negative 4 to fit our sum product rule. So I'd have x minus 3, x minus 4. Okay, so far, that's the factored form of the expression. This should all be familiar to you. If this isn't familiar to you, like I said, you might want to go back and watch another video because I'm not going to talk about how to do this. I'm just going to show you that I expect you to know this to be able to follow along in this video. Okay, so we're good on this. Let's look at some trickier times when we can't factor by splitting the middle and we can't factor by factoring out a greatest common factor. Here's an example. Say we had to factor the expression 6x squared plus 17x plus 12. Well, if you're good at factoring with the greatest common factor, you might first start by checking, is there a greatest common factor of these three terms? And there isn't. And the next thing you'd want to check is, can I factor with the sum product rule? But we've never seen the sum product rule used when there's a number out in front. Generally, this kind of expression is often noted like this: ax squared plus bx plus c, where a doesn't equal 1. Right? And you can kind of see how this expression fits that rule. Well, a would be 6 in this case, right? It's not equal to 1. B is 17, and c is 12. Okay, so I can't factor it with the sum product rule, but I might be able to factor it by just thinking to myself, well, I bet what's going to multiply to 6x squared? Well, it might be 6x and x. What else would multiply to 6x? Well, it might be 2x and 3x. And if I wanted to guess and check there for a while, I might also think, well, how do you get 12? You get 12 by multiplying 1 and by multiplying whatever goes here and here. So 12 could be like 3 times 4. Well, if I do 3 and 4 here, I'm not going to get exactly 17. And if I do 1 and 12, I don't think I can get 17 either. Right, because if I wanted to, I could get close to 17, I think, if I did. No, I couldn't get close to 17. So this one I don't think is going to work. And here, let's see, it might work if I put, let's see, if I put plus 3 here. So I'd have, if I were distributing it back, 2 times x would give me, or 2x times 3x, 6x squared. 3 times x plus 9x. And I need something that multiplies to 12, so I'd have plus 4. I'd also have to do 2x times 4, which would be 8x, and 3 times 4 for 12. When I simplify that, I get the same thing I started with, so I know I got the right answer. Okay. So I could guess and check my way there on a problem like this, but that might be really hard sometime, depending on what this number is and depending on how these play out. It might be really hard to figure this out. So there's a better process for doing it. And it kind of works a little bit backwards from this. Notice how 9x and 8x come out of the middle here. The technique of factoring that I'm going to show you right now is called splitting the middle. And we can figure out what these two numbers have to be by figuring out a little rule from these guys. So what's the rule? It's kind of like the sum product rule. We'll start with 6x squared plus 17x plus 12. And instead of looking for what multiplies, what has a product of 12 and a sum of 17, to figure out the product that we're looking for, we're going to multiply 6 and 12 together. Okay, 6 and 12 make 72. And I'm going to look for the two numbers that multiply to this guy. So I have a product of 72 and a sum of 17. And that should remind you of the sum product rule, except for the fact that we multiplied these two. All right, so sum of 72, or sorry, product of 72, sum of 17. All right, well, product of 72. Those two numbers could be 1 and 72. They could be 2 and 36. They could be 3 and 24, 4 and 18, 6 and 12, or 8 and 9. And they need to have a sum of 17, so I'm going to pick 8 and 9. Okay. So now I'm ready to do the special part of this technique, which is called splitting the middle. So I'm going to say split the middle. Take this expression, write it again, and this time, instead of writing the middle term as 17x, we're going to split it into